All right, in this video, we're going to find the slope of a graph at a particular point using the limit definition of the derivative. And the limit definition of the derivative that we're going to use is going to be the one that we're going to use less often in this class. But it's going to be that f prime at c is equal to the limit as x approaches c of f of x minus f of c over x minus c. Go ahead and write that one down. We're going to be using that in all of these problems. It is a difference quotient here that might not be quite like the difference quotients that you have used so far. This x minus c is going to come out as a factor in the top when we're done, and it will cancel, and then we will evaluate that limit. So let's go ahead and get started here with number 17. Number 17 is such a simple function that it comes out to be a little bit different than the other functions that we're going to be dealing with because it is a constant function. But let's go ahead and write down f prime at 0 is my x value that I want to evaluate at, is going to be equal to f of x, which is the function -1. That's all it is. There's no x's in it, minus f at 0, which f at 0, they give us the point there is also -1 over 0 minus over x minus 0, sorry, over x minus 0. Leave that x in there. So this comes out to be 0 over x, which is equal to 0 as long as x is not equal to 0. And that's fine because we are approaching 0, but not ever getting there. So the limit is going to be 0. Now that one's hard because normally you think 0 over 0, you would plug in and you say, I don't know, that's undefined. But as long as 0 is divided by any non-zero number, which is what's happening, as you get close to 0, it's going to be 0. And the slope of a horizontal line here, which it is, the function was f of x is equal to -1. And the point given was 0, -1. The slope of any horizontal line, y equals a constant, is 0 everywhere along that line. So because this function was so easy, the derivative was actually a little hard. You'll see that the next one is going to work out a little bit more like we expect. So we have f of x is equal to 13 minus 4x at the point 3, 1. So we want limit as x approaches 3 of f of x minus f of c over x minus c. So that's going to be equal to the limit as x approaches to 3 of 13 minus 4x minus 1 over x minus 3. That's limit as x approaches 3 of 12 minus 4x over x minus 3. That's the limit as x approaches 3. I'm going to pull out a -4 as a common factor here, and that's going to leave me with -4x divided by -4 is x. 12 divided by -4 is a -3. I wanted to pull out that -4 to get that order of subtraction the way that I wanted here, so that as I'm approaching 3, this is approaching something that's non-zero over the same non-zero number that's going to make a 1. And so this is going to be limit as x approaches -3. I'm sorry, x approaches 3 of -4. There's no x's to plug into anymore. That's a constant -4. That makes sense because this is a line where the slope stays constant, and the slope is -4 mx plus b. They just wrote it backwards so you wouldn't recognize it right away, but the slope should be -4 at every point on that line. So that one makes sense too. So we have 2 of them that we should have been able to look at and know what the slope was, but not so with the next problem, number 21. 21 says f of x is equal to 2x squared minus 3, and we're given the point 2, 5. When we plug 2 in, that's a 4. 4 times 2 is 8. 8 minus 3 is 5. Yes, it is. So we want f prime of 2 is equal to limit as x approaches 2 of f of x minus f of c, which is right there, over x minus c, which is right there. And so we're going to have limit as x approaches 2 of 2x squared minus 3x minus 5, that's a -8, over x minus 2 is, let's pull that 2 out, and that makes an x squared minus 4. And that x squared minus 4 factors into an x plus 2 and an x minus 2 over an x minus 2. And these are getting close to 0 over 0. They're the same non-zero number over one another, so they form a 1. And then I'm able to take the limit here, and we'll plug in 2 times 4 is 8. Let's look now at number 23. This is f of x is equal to x cubed minus 4x at the point -1, 3. So let's find f prime at -1. It's going to be limit as x approaches -1 of x cubed minus 4x minus 3 over x minus a -1. So that gives us limit as x approaches -1 of x cubed minus 4x minus 3 over x plus 1. My goodness, what do we do with that? Well, we know for sure that we're not going to be able to just stick in -1 and evaluate, because we know f of x cubed minus 4x is 3, and 3 minus 3 will be 0, and -1 plus 1 will be 0, and we'll get 0 over 0 and we'll be stuck. So I think that we better use synthetic division or long division. I'm going to use synthetic division here to help me. I'm going to say that I know my 0 is -1, and my coefficients here are 1 and then 0x squared, and then -4 and -3. Bring down that 1. 1 times -1 is -1. And then -1 times -1 is a +1. and then -1 times -3 is a +3. So that leaves me with limit as x approaches -1 of x plus 1 times x squared minus x minus 3. Those are my coefficients, 1, -1, -3 over x plus 1. Those x plus 1s will cancel, leaving me with the limit as x approaches -1 of x squared minus x minus 3 is a -1 squared minus a -1 minus 3 is 1 plus 1 minus 3 is 2 minus 3 is -1. One more problem for this video. We have f of x is equal to 2 root x, and the point given to us is 4, 4. So we want to find f prime of 4. F prime of 4 is going to be the limit as x approaches 4 of 2 root x minus 4 over x minus 4. Now, I'm going to go ahead and pull out this common factor of 2 to get me started. It's not helpful to my problem. I'm just going to put it outside my limit here. Now I want to rationalize that numerator. So I'm going to multiply by root x plus 2 over root x plus 2. Don't forget your 2 that's outside your limit. If you're going to put it out there, it needs to stay out there the whole time until you're ready to evaluate. And so root x times root x is x. Root x times +2 is +2 root x. -2 times root x is -2 root x. And -2 times +2 is -4. Your teacher may tell you that you don't need to write those middle terms. I'm just showing you because if I didn't show you, someone would ask, how did you get that? And I don't want to have too few steps. I'd rather have too many steps. Show you we're going to get to the same place here. So x minus 4 in the numerator, x minus 4 in the denominator, root x plus 2. We're going to cancel, and that gives us 2 limit as x goes to 4 of 1 over root x plus 2 is, don't forget that 2 times 1 over root 4 plus 2 is 2 over 2 plus 2. That's 2 over 4 is 1/2. So that's it for this video. We'll come back next time and talk about the other form of the derivative where you're not given a point, you just want to find the generic derivative function, f prime of x for any x value. And we have a slightly different form of the limit definition that we're going to use that looks more like the difference quotient that you practiced so much in pre-calculus. We'll do a few examples of that next time, and I'll see you for the next video.